Alright, so hopefully this is the last video for tonight anyway. Binary molecular compounds. Remember again, we have two types of compounds. We have ionic compounds and molecular compounds. They're two of the three types of substances. The third substance is an element. So, anyway, okay, so we're going to talk about molecular compounds line on the periodic table. Just because it's binary, binary simply means that it's made of two different elements. It can have more than two atoms. So water's binary because it's only made of hydrogen and oxygen, but it actually has three atoms because it has two hydrogens and one oxygen. Molecular compounds are fairly easy to name. The subscripts become prefixes. You don't have to memorize the prefixes. They're going to be on your helper sheet. You just have to be able to use that. You don't have to use mono if there's only one atom of the first element. I certainly won't mark it wrong if you choose to use mono, but it's not necessary. And the second element always ends in "ide." So if we look at our first example here of Cl2O8 and how we name this, again, the first question always needs to be, is this ionic or molecular? This is a molecular compound because it's made of two nonmetals. Because it's a molecular compound, to write the formula or to write the name, we simply have the subscripts are going to become prefixes. So this is chlorine. The prefix for 2 is di, so this is di. Chlorine. I-N-E ending because it's the first element. And then again, O is oxide, okay? Oxide because it's the second element, so oxygen becomes oxide. And the 8, I probably shouldn't have chosen 8, not having my helper sheet, but I think it is hepta. And so I think the name for this would be dichlorine heptoxide. If I'm wrong about this prefix, then I apologize. But again, all we do to name these is we combine the name, or we take the subscripts become prefixes. Okay, right. So dichlorine heptoxide. In terms of writing the formula when you're given the name, again, it's just basically backwards. So the prefixes become subscripts. However, unlike ionic compounds, where you remember that those 4 steps were symbols, charges, crisscross, lowest whole number ratio, for molecular compounds, you don't make it the lowest whole number ratio. You never reduce the subscripts. So if we look at our example of dioxygen difluoride, again, we still always want to start with that question of whether this is ionic or molecular. We know this is a molecular compound because it's made of 2 nonmetals, okay? So because it's a molecular compound, we are going to take these prefixes and make them subscripts. So we're going to write our symbols. For oxygen, it's O. For fluoride, it's the F. And then because this prefix is di, this becomes a 2. And because this prefix is di, it becomes a 2. And we leave the formula this way. Okay, it would be wrong to write this as OF because we do not make it the lowest whole number ratio for molecular compounds. Finally, in this 5th section of your textbook, we have acids. In terms of acids, you really don't need to worry about it. I won't use acid names. I will name acids as ionic compounds. So, for example, if I asked you to write the formula for something like hydrogen phosphate, which actually is phosphoric acid, okay, I'm going to call it hydrogen phosphate. And again, you go through those same steps. So the first question is this ionic or molecular? Because I have this ATE ending, remember that's my indication it's a polyatomic ion. So this is an ionic compound. So I'm going to do symbols, charges, crisscross, and make sure it's the lowest whole number ratio. My symbol for hydrogen is H. It's in group 1A, which means it has 1 valence electron. It's easier to lose 1 than to gain 7, so it has a positive 1 charge. Phosphate you have memorized, it's PO4 with a charge of -3. I crisscross down. I don't have to worry about parentheses here because I only need 1 phosphate. So my formula becomes H3 PO4. So again, with acids, I will not call them by their acid name. I will name them as an ionic compound, and you'll be able to use your knowledge of memorized polyatomic ions or your helper sheet to figure out their formulas.